We're live, we're recording, we're rolling. Let's do some math. So we're going to do some word problems. Set up and solve. What they mean by set up is, of course, you have to show me with the equations. Don't try anything silly like just sort of guessing and checking till you find the right numbers. I'll give that a big fat 0 if that's on a test. The whole goal here is not necessarily to solve these problems because they're not meant to be hard problems. They're not all that challenging. The goal is to get you to think algebraically. The goal is to get you to look at a situation and go, oh, I can apply my algebraic reasoning to this situation. So two numbers have a sum of 40 and a difference of 6. This will be the easiest half mark you ever get from me right here. Let x and y be the numbers. That's it. That tells me that I have two numbers. So I have two numbers that have a sum of 40. What is sum telling you to do? That is add. So they have a sum of 40 and a difference of 6. Now, we have learned two different algebraic methods to solve equations, substitution and elimination. This one's pretty much set up for elimination, right? I can just add those equations together and it eliminates my y. So that's what I'm going to do. So I'm going to add those two equations together. X plus x is 2x. 40 plus 6 is 46. I didn't bother writing y. I've had people ask me, should I write 0y? Because that's what happens when you add positive y to negative y. Go ahead. 0 times anything is still 0. You're just wasting lead from your pencil. I don't need to see that. If you want to write it down, you can go right ahead. I wouldn't mark it wrong. But certainly I don't need to see it. So I've found my x value. Now I'll go to one of the equations and substitute that in. 23 plus y then equals 40. I'll minus 23 from both sides. And now as a check, or a verify, I don't care whether you use the word verify or check, I'll use the other, oh, it's 17, not 7, thank you, holy cow. I'll use the other equation, the one I didn't use in that second last step there, to make sure that I have the right answer. Does 23 minus 17 make 6? Yes, it does. And now, it's not enough to just put x equals this, y equals that, or put them as coordinates, because this was a word problem. It had context. It had a situation. Therefore, the numbers are 23 and 17. You want a sentence. It doesn't have to be a grammatically correct sentence. I don't think your English teacher will want you to use the therefore symbol in the essay, right? So we're not marking you for spelling or grammar, but it has to be a sentence. And again, it's really just telling me what the answers are. That's the second easiest half mark you'll ever get from me. So these parts here are part of solving a word problem. You lose the half marks if you don't have them. Okay? Together, those two things are one of the 3 or 4 marks that you'll get for solving a word problem. And then, of course, if this was, say, 3 marks, so those two things are 1 mark, I'd give you 1 mark if you just got the right equations. And then I'd even give you a mark if you had the wrong equations, but you solved your equations correctly. Please don't take that as license to just make up any old thing. I mean, do try to make up the right equations. Okay? Any questions on how I'm kind of approaching these? Yeah, just right. Just make up any equation you want. And, hey, I'll get a mark for that. I suppose by the letter of the law, I guess I would give you a mark, but I'd be very disappointed in you. Okay, next one. Set up and solve the linear system. At McDonald's, 2 cheeseburgers and 1 large fries have 1,100 calories. 1 cheeseburger has 200 fewer calories than 1 large fries. How many calories are in 1 cheeseburger and how many calories are in 1 large fries? So let x equal number of calories in a cheeseburger. And I'll use y to be the number of calories in a large fries. There. Again, easiest half mark you're ever getting. You just have to tell me what x and y mean. If it's a geometry problem, you can even tell me with a diagram. But this one's words, so we'll use our words. All right. 2 cheeseburgers and 1 large fries. So 2 x's and 1 y have a combined calorie total of 1,100. That's one equation. What's my other equation? One cheeseburger has 200 fewer calories than one large fries. So one cheeseburger has 200 fewer than one large fries. So I could say that if I take the large fries and minus 200, it would equal the same as the cheeseburger. If you said x plus 200 equals y, that's the same thing. That's fine. This one to me is kind of set up for substitution, right? Because one of them is in terms of the other. It's kind of isolated for x already. So I'll use substitution on that. 2 times x plus y can be replaced by 2 times what x equals. Oops, missed a 0. There we go. And then from there, I know that that's 2y minus 400. Because x equals this. So I replaced my x with what I know it equals. If you had the equation x plus 200 equals y, I'd have done it the other way. I'd have substituted for the y and put x plus 200. Either way, we'll get the same answer in the end. For those of you at home that couldn't hear that, the question was, why did I substitute for the x? Because that's kind of the way this one was set up. Without having to do any work and rearranging anything, boom, x equals this. I can just replace this x with what I know that it is equivalent to. And now I have an equation with one variable, which is where I want it to go, right? I can only solve an equation when it has one variable. 2 y's and 1 y is 3 y's. I'll add 400 to both sides, giving me 1,500. I'll divide both sides of the equation by 3. And there we go. I have found that one large fries has 500 calories. I got to find my x number, so I'm going to put that y back in here. And x is equal to 300. So my therefore, one cheeseburger has, x was the cheeseburger, right? Yeah. Has 300 calories. And a large fries has 500 calories. And there we go. That's a complete answer. It's defined the variables, it made up 2 equations, it solved them. I can follow the work. I can see where all of the thinking is. That's the way I want to see your work look when you do word problems for me on an assessment. Sorry, can you say that again? I don't know. Yeah, I don't know. I'm not sure. Is this an accurate representation of how many calories there actually are in fast food burgers and fries? I actually don't know. I didn't make these notes. I don't know. I don't know if they were researched.
There might be 1,100 in a Big Mac alone.
I honestly don't know. Okay, set up and solve the following system. Paras has a total of 30 $10 bills and 5 dollar bills. Okay, so you guys, and 5 dollar bills. If the total value of the money Paras has is $200, how many of each type of bill does she have? You know what? I think that's missing a word. Yeah, I think this is supposed to say 5 $5 bills. Can you add another 5 to that? No. She has 5 $5 bills. I bet what happened is like some sort of autocorrect pointed out that, hey, you typed the same word twice. So yeah, that because I know how this, I can see how this question is going to work out. They meant that you have 5 $5 bills.
No. It's 30 $10 bills.
And 5 $5 bills.
30
Oh.
$10 and $5 bills.
No, that's not the. First of all, we haven't had a dollar bill in Canada since 1985 or 86.
Exactly. The bills are worth $5.
It could be the U.S.
Yeah. She has
US
30 $10 bills and oh, I see. Oh, okay.
US dollars.
Oh, I'm misreading this. She has a total of 30 $10 bills and $5 bills, but we don't know how much of each type she has. Okay, that's right. We don't need an extra 5. You're right. I'm misreading this. Okay, Paras has a total of 30 $10 bills and $5 bills.
I think
If the total value of the money Paras has is $200, how many of each type of bill does she have? Okay, let's define these variables before I get confused again. Let X equal the number of $5 bills Paras has, and let Y equal the number of $10 bills. Now, these kinds of questions always have sort of two types of equations that are always similar. One of them is just a total number of pieces of paper, total number of bills, and the other is a total amount of how much they're worth. So we have a value equation and a number of objects equation. So let's do the objects equation first. X of these plus Y of those is 30 total things, my object equation. My value equation, if you have one $5 bill, that's $5. If you have two $5 bills, that's 10. 7 $5 bills is 35. How am I getting the value? I'm taking the X number and I'm timesing it by 5. $10 bills work the same way. If you had one of them, that'd be times 10, right? So 1 times 10, 2 times 10, 3 times 10. In this case, I have Y of them. I don't know what Y is yet, but I know however many bills Y is, when I times that number by 10, it'll give me their value. And I know the total value of all the bills is $200. All right, how do you want to approach this one? I think I'm going to use elimination. I agree with that. But I think, what do I notice about this second equation?
You can divide it
Yeah,
by 5.
every single coefficient and constant is divisible by 5. So I'm going to divide this equation by 5. So now it's x plus 2y equals 40, right? Because 5 goes into 24 times with a 0. And then from there, let's subtract the other equation. Whenever I'm subtracting a whole equation, I always put it in a bracket like that so that I remember to subtract all 3 parts of it. You get where I'm going with that? X minus x is 0. That was the idea. I eliminated x. But you'd be amazed at how many people now will just look at this and go, oh yeah, 2y plus y is 3y. No, 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 don't forget we're subtracting this time. 2y minus 1y is 1y, and 40 minus 30 is 10. Then I'll go back to maybe my first equation because it's smaller. X plus 10 is equal to 30. I'm replacing this y with 10. And x is equal to 20. I could do a quick check with the other equation. Does 5 times 20 plus 10 times 10 make 200? Yes, it does, because that's 100 plus 100, so it works. So I'm ready for my conclusion now. Therefore, Paras has 25 bills and 10 $10 bills. There we go. I misread this question the first time I looked at it. Now it makes total sense to me. All right, so there's 3 examples of the kind of word problems you might see, and you actually had some of the homework that are harder than these already. If you're still fighting with them, you can have some time later today to keep working on them, and I can give you hints if you're stuck. But before we kind of go to some, actually I think we'll do maybe one more word problem, but we'll do it after we do this next section. The next section, let's do some of these. Linear equations where fractions are going to get involved. Now you're looking at the first question going, well, I don't see any fractions there. Well, hold on a minute. The answer is going to be fractions. So let's see. What will I do with this? I'm going to use elimination. So I'm going to take this equation and I'm going to multiply it by 2. So the first equation I'm going to leave alone. It's minus 2x plus 2y equals negative 4. But my second equation now looks a little different than it did a second ago. Now it's 2x plus 2y equals 2. And now, if I add those equations together, I eliminate x. So I'm going to get 4y when I add them together. And I'm going to get, I'm going to get negative 4 plus 2 is negative 2. Then I'm going to divide both sides of the equation by 4. And then I'm going to realize that that fraction simplifies. No, I don't want decimals. If the question didn't start with decimals, I don't really want decimals in the answer. So that's where we go from there. Now, pick the equation that's the simplest, because I'm going to have to plug a fraction into it and work with it. So I might as well go back to this original equation here that had 1 for coefficients. When 1x plus y, and I'll replace y with the fact that I know it's negative a half, equals 1, then I'll add 1/2 to both sides of the equation. So you could say that's 1.5. I think we'd prefer an improper fraction to a mixed number. So that's 1.5, which is 3/2, and there's my solution. 3/2, comma, negative a half. Now, obviously when you're working with fractions, doing the check becomes harder and more steps, but it does still work. If you really had to show a check, you just plug those two things in to the other equation. And remember how you multiply a fraction by a whole number, right? You treat the whole number as if it has a denominator of 1, and 2 goes into 2 once, 2 goes into 2 once. So I think of that as negative 1 times 3, and as 1 times negative 1. And yeah, that does work. So that is the correct solution. Okay? All right. Now, I guarantee you the next one's going to have even tougher fractions than that. So I'll say maybe don't bother with the check, but why don't you see if you can find what those fractions are? And I would say this one's very nicely set up for addition. I was going to say for subtraction. Still elimination. Whether you add or subtract, you still call it elimination. But do you get how I see the subtraction there? Yes. The 4 y's will cancel each other if you subtract. Okay, so I'll let you try this one. I'll give you a minute, and while you're doing that, I'll quickly run attendance here. And then I'll try to catch up to you. Oops. Oh, oops. I don't want that to open over there. I want it to open over here. Okay, there we go. And file. And print. Actually, that might not have worked. No, that did not work. Oh, hang on. You can't see anything there, guys. Sorry about that. There we go. Keep forgetting that when I move windows around, for some reason it always automatically takes me off of my OneNote screen. I don't know why it does that. It's annoying. There we go. That went through. Okay. And all right. Let's see if we all agree on the same answer. So I am going to subtract these two equations from each other. And again, I like to put a bracket around it when I do that. So negative 2x's minus another x is negative 3x's, right? Negative 2 minus another 1. The 4y's go away. And then careful here, negative 20 minus 8 more is negative 28. So I did tell you this was not going to be a pleasant fraction. X is 28 thirds. Well, at least the negatives cancel each other. But 3 doesn't go into 28. I don't really want a mixed number. It's actually much more useful to just stick to the improper fraction since I'm going to have to multiply with it in the next step anyway. Right? Because my next step is to go back and plug that in. I guess I don't have to multiply. I can use this equation. But I'm going to plug it in for x. So 28 thirds is this x plus 4y equals 8. Okay. You can move the 28 thirds to the other side and work with fractions, or you can use the get rid of fractions method. Times the whole equation by 3. So if I times the whole equation by 3, that's 28. That's 12y, and that's 24. So 12y would equal 24 minus 28. And then y is equal to negative 4/12. Costs you half a mark if you stop there. What can you do with 4 and 12? Divide top and bottom by 4, and that becomes negative 1 over 3. And there it is. That is my answer. When x is 28 thirds, y is negative 1/3. And this is where we say, okay, maybe it wasn't as much fun as other algebra because I had to work with fractions, but could be worse. Imagine trying to find the solution by graphing. Ugh. Yeah. Question? Okay. Did you get the same answer as me? Well, then you have the wrong answer because that's not what it is. Okay, we can do that. So you decided to simplify it by 2. That's actually a good idea. I probably should have thought of that. Then you added it to this equation. Okay, so those things eliminate now, and you get this. Right? And then you divide both sides of the equation by 6. And you get this. Okay, but the other one's not going to be 28 because, okay, now what did you do with this number? Where did you substitute that? So you put it into the second equation. So x plus 4 times 1/3 equals 8. Oh yeah, thank you. I lost my negative. There we go. And you took what? How? What do you mean you took 3 to the other side? You can't just pick things up and move them because you don't like them there. How do you actually work with equations? You can add things to both sides of the equation. You can subtract things on both sides of the equation. I guess what you're thinking of is I kind of don't want to deal with this fraction, so you times both sides of the equation by 3. That doesn't mean you get to just pick up the 3 and move it to the other side. You'd have to make this thing times by 3 and this thing times by 3. Right? Now you can say 3x minus 4 equals 24, 3x equals 28, and I get the same answer that we had a minute ago, 28 thirds. Okay? If you don't want to actually, if you don't mind working with the fractions, it's not that hard. Alternate strategy here is to actually just work with the fractions. 4 times negative 1/3 is negative 4 thirds. Now, again, you like to think I moved this to the other side, but always remember, there is no math rule that says you can just pick things up and move them, right? Think of, again, the equation is a seesaw, and these two parts are on one side, and this part's on the other. So without tipping the seesaw over, how does this thing actually get to move over there? You have to add so that you cancel it on this side, but you still have it on that side. So that's the way I have to think. So x would be 8 plus 4 thirds, and then using common denominators, 1 would be 3 thirds, so 8 would be 24 thirds. So no matter which road we take, we always kind of end up in Rome. X is 28 thirds, y is negative 1/3. In this case, all roads lead to 28 thirds. So there we go. So there's a couple of examples of where our answer ends up a fraction. And of course, for sure, we don't want to deal with decimals when we're dealing with things like thirds because they end up repeating. Question? There's no other answer to the equations, I'm afraid. There's other ways you could do it, but the only answers that are true, The only two places that these two lines cross each other are when x is 28 thirds and y is negative a third. Sorry? So what is your answer? Okay. Oh, so you did it. Okay. So you did it a different way yet. So you did. So you looked at this equation and you left it alone. And then you took the second equation and you doubled it. Did you remember to double the y? And did you remember to double the 8? There's your problem, right? When you double an equation, you got to double all the terms of it. The whole thing got times by 2. So if you do it this way, guess what's going to happen? 4y plus 8y is 12y. Negative 20 plus 16 is negative 4. And there's my negative 1/3 again. It's inescapable. It's Thanos. It is inevitable.
Oh, that's Spider-Man. I am Iron Man. No, that's Spider-Man. Everywhere I go, I see him.
All right, moving along. Now let's try ones where we have fractions to start with. We did a couple of these, we did one of these the other day because I had a couple in your homework. But let's do them formally in your notes now. Solve this system of equations. Okay, I would rather not work with this many fractions. So I'm going to take this equation and I'm going to multiply it by a number that will cancel all of the fractions. It's going to be 21. That's the lowest common denominator of 7 and 3. So 21 times 1/3 is 7. So that's 7x. 21 times 2/7. 7 goes into 21 3 times, so that's 3 times 2 is 6. And 21 divided by 3 is 7. 7 times 14 is 98. The numbers get a little big on this one. No, I multiplied it. Right? Because think about how that works. If you need to see how that works here, let's just do some scrap up here. 21 times 1/3, right? Remember, you always treat a whole number like it has a denominator of 1. And then you could go top times top, bottom times bottom, and get 21 over 3, which simplifies to 7. But I like looking and canceling common factors. If you want to think of that as divide, you can. It's like I went 21 divided by 3 before I did anything, right? And then for the next one, I had 21 times 2/7. So if you like thinking of it as the 7 divided into the 21 and left a 3, remember that when you first learned BEDMAS, some people do call it BEMDAS, because it doesn't matter whether you divide or multiply first if that's all you have to do, are those two operations. So that's where the 6 came from. And then this 98 came from 21 times 14/3. So again, I know 3 goes into 21 7 times, and then I went 7 times 14. 7 tens is 70, 7 times 4 is 28, and that's how I got the 98, by putting together 70 and 28. The second equation is actually much easier than the first, because all the denominators are the same. A 7 should take care of all of those denominators. 7 times 1/7 is 1. 7 times 1/7 is 1. And 7 times 1/7 is 1.
Incredible.
Well, that one's nice. But I can't solve this the way it is. I'm going to have to either rearrange this and use substitution, or multiply this by something so that I can use elimination. Let's use elimination. Let's times this equation by 6. So I'm going to leave the first equation alone. And then for my second equation, I'm going to multiply everybody here by 6. 6x's is 6x, 6y's is 6y, and 6 1's is 6. Now I can add those equations together and say that that's 13x. What's 98 plus 6? 104? Sure. And I don't know about you, but in my grade 3 classroom when I was young, I think the times table on the wall ended at 14 times, or at 12 times 12 is 144. That was the bottom right corner of that poster. So I have seen, however, especially in Europe, times tables that go all the way up to 20 times 20. Anybody got their 20 times 20 times table memorized, which means they know their 13s? Let's skip count by 13s.
I know what 13 squared
13, 26, 39, 51, no, 52. That's better. 52, 65, 78, 91, 104. Okay, who had their fingers going? Nobody had their fingers counting. You guys just failed grade 3 times tables. You have to use your fingers while you skip count.
Again.
I have a calculator.
You're not allowed a calculator, I'm sorry. And every once in a while, the numbers do go past your times tables. You, of course, have scrap paper if you want to do scrap work. But okay, here's what you know. If you times a number by 3 and it ends in a 4, it must have been an 8. There you go. That's the only way it works. So this is 8/13. So x is 8. And then I don't have to go back to these original equations because these equations are the same equation. They equal the other equations. So I can go back to this nice easy one and plug in an 8. That makes life a little easier. So negative y is negative 7, so y is 7. And that's interesting, even though we started with big, gnarly fractions, the actual solution are whole numbers, which is cool. Okay, very nice. All right, some of the people who are probably even better with numbers than I am would probably look at this and go, you kind of wasted your time timesing this by 7 and then timesing it by 6. Couldn't you have noticed from the beginning that you could have times this first one by 42? Then you wouldn't have had to have times twice. And I would say to that, I could have if I'd have wanted to, but no, I probably wouldn't have noticed that. I'd have probably done it in 2 steps. All right, next. Yeah, there's 42 again. The answer to life, the universe, and everything. All right, let's do the next one. I tell you what, let me give you a minute and you can try the next one. Obviously, you're timesing the top thing and the bottom thing by something different. You need to times the top equation by a number that'll cancel 4 and 2. And then you need to multiply the bottom equation by something that'll cancel 4, 6, and 3. So I'll give you a minute to think about that. Don't say it out loud. Let people think about it. I'll go pick up my copying while you're thinking about it. Okay, let's see if I can catch up to you now. Okay. I would multiply that first equation by 4, giving me 1y, 4x's, minus 4x's, and 6. Did anybody go, oh, I went 4 and 2 both go into 8, and then you multiply by 8? You know what? You shouldn't be wrong. You just have an equation that has a 2 here, an 8 here, and a 12 here. It'll still work. Stay with it. Meanwhile, down here, I think the number I'm going to multiply by is 12. So 12 times a quarter is 3. 12 times a sixth is 2. And 12 times a third is 4. Now, what do you want to do with this? You could double this equation, and then adding them would eliminate the x's. I think I'll do that. So I'm going to double this equation. So the first equation I'm leaving alone. The second equation I'm doubling. 6 4, and 8. So I add those together and I get 7y's. I add those together and I get 14. So once again, we started with fractions, but we have a whole number for one of our solutions. Let's get the other one now. I'll go to this equation right here. That looks like the easiest one. I'll replace the y with a 2. Then I'll minus 2 from both sides. And that's an integer too. Isn't that nice? And you could do a check if you wanted. You could plug these two numbers into either of those equations, and you should get a true statement. Here, let's do one of them. I'll pick the one that looks easier. I'll pick the first equation. Go away. So a quarter times the y number, which was 2, minus, oh, careful, minus the x number, and the x number is -1. So minus -1. I like doing this, minus -1. In my head, I just rotate the negative and put it on there and make it a positive. And then that equals, what does that equal? That equals 3/2. Is a quarter of 2 plus 1 equal to 3/2? I believe it is, because that's 2 over 4, and that's 1 1/2, and that's what 3/2 is. I think we got it. So there's some examples of fractions. We have some room at the bottom of this page. I want to do one more word problem with you. You know what we don't have in any of the examples in the notes? Actually, kind of. I was going to go decimals with words. I was actually going to go with percents. Percents, because I think there's a couple in the homework that involve percents. So this is going to be example 5. You actually have to copy this one. We need a name. Let's go with Al. Al invested $2,000 in 2 different investments. One has, and you know what, I should probably make that a new sentence. No reason for this to be a run-on sentence. One has an annual interest rate of 8%. The other has an annual interest rate of 10%. After 1 year, the total interest earned, it's an R, was $190. You can probably almost guess what the actual question is. How much did Al invest in each fund? I think we're going to use X and Y.
It's a long sentence.
No, I made it into 2 sentences. 3 even. 4 if you count the question as a sentence.
A long bit of writing.
You guys are spoiled. I've been handing you out notes packages so you don't have to do any real writing.
Exactly, that's the way it should be done.
Well, you know, the argument can be made that if the goal is to prepare you for post-secondary learning, note-taking is a skill that you have to develop. You're not born knowing instinctively how to write down what's happening, think about what's happening, and listen to the words that you're hearing all at the same time, right? You weren't born knowing how to walk and chew gum. You had to figure that out, you know?
That's why I just think and listen and then record it.
Okay, well, there you go. You should be able to do all 3. Your brain's an amazing thing. It can multitask. Sorry.
The way I write notes is so different from the booklets, it doesn't even apply.
But as long as you can understand them, that's the important part. All right, let's figure this out. So again, here comes the half mark that if you forget it, you'll be sad. It's such an easy half mark. Tell me what x and y mean. Let x equal amount invested in, or how about instead of in, how about at? How about I make a scribble? At 8%. And then we'll let y equal the amount invested at 10%. Okay? So now what are my two equations going to look like? Okay. Let's do the easy equation first. X and y are amounts of money. How much money did he start with? 2,000. So there's the easy equation. All the money in total was $2,000. Now, careful here. If you invest something at 8% interest in a year, you should have 8% of that amount. And if that amount is X, you should have 8% of X. How do you write 8% as a number we can work with? 0.08. That's it. You have to make sure that you remember that, oh yeah, percentages are fractions of 100. So you divide that number by 100, and you get that. So 8% of some X amount of money plus 10%, which is 0.1, or 0.10 if you like, of Y amount of money is equal to $192.
190.
Oh, why did I think it was 192? You're right, it's only 190. Thank you. I don't know, I misread it. Okay, would you like me to show you a very common mistake people make? People will go, oh, I don't want to deal with decimals. So if I change them both to just percents, there you go, 8x plus 10y equals 190, and move on with my day. Do you see why that won't work?
190%?
Yeah. How can those two numbers be the same? They can't. If you really want to do it this way, and I'm not saying that that's actually wrong. In fact, I might be persuaded to do it that way. I might change this to 8x plus 10y, but remember that I have to times this number by 100 as well, or else it's not the same equation anymore. So it's actually 190 and then put 2 more zeros on it. Now, if I'm changing that equation, I could change this equation as well. So it's x plus y equals 2,000. What should I change that one to? How about I change it to something where if I do a subtraction, I eliminate something? How about we just times it all by 10? I'll have 10 x's, I'll have 10 y's, and instead of 2,000, I now have 20,000. But now, I can subtract those equations and get an answer. 10x's minus 8x's is 2x's, 10 minus 10 is nothing, and 20,000 minus 19,000 is 1,000. And that's then going to be x is equal to $500. And go back to that simple equation we started with. X plus y is 2,000. So 500 plus y is 2,000. So y is 1,500. And hopefully you still, if you don't have any more room, you could always write on the back. Therefore, what was this kid's name again? Al. Therefore, Al invested $500 at 8% and $1,500 at 10%. So why don't people invest all of their money in whatever the highest investment they can find is? That's right, because the higher the interest rate of return, the bigger the risk. There is high risk, high reward. You've done some personal finance, you know how that works. So I just wanted to do one equation like that, one word problem that involved some percents, just in case you run into those in your homework. All right, I'm going to stop the recording now. I think that's good enough for the lesson. People can watch that later if they want.